The Nobel Prize awarded to Mr. Kao is behind the production of optical fiber. Mr. Kao in the 1960s, 1970s began to look at how optical fiber could be used to transmit optical signals over long distances and what material to make it out of in the first place, because the purity is in the ppb, particle per billion units. I don't know if you can imagine what that little number is, but there are roughly 8 billion people on the earth, so if we're talking about ppb units at the glass purity level of that fiber, that's 1 or 2 people on the globe as the impurity level of that fiber. That's how clean it has to be usable for long distance transmission. Optical fiber is made of 2, let's say, such major areas. The first one is called the core. The core measures about 8 micrometers. Then the rest of the fiber is the cladding, which measures roughly 125 micrometers. The whole fiber is made of very pure quartz glass, and the fiber is then encased in what is called primary protection, which nowadays measures only 200 micrometers. This 200 micron technology is essentially the most advanced way of producing fiber today, and it is being installed in the smallest cables available today. Here we can look again at a very modern construction of 144 fiber cable with 200 micron fibers, which is what we use to connect distribution points within the optical access network. The optical signal is propagated in the fiber by light, which is in the infrared spectrum, and for the transmission or propagation of that signal in that fiber, we use what is called total reflection, where it is at the interface between the core and the cladding that there is total reflection of that particular signal in that fiber, and therefore long-distance propagation. So the attenuation caused by the fiber, for example, is not due to some of the energy being drawn away from the fiber, but is essentially absorbed by the impurities or material imperfections in that material. Of course, the world and the Czech Republic started out on metallics in the form of coaxial cables or twisted pair. We can see in the beginning paper cables or lead-sheathed cables, which gradually moved on to more modern constructions with plastic sheaths filled with gel to prevent the gel from spreading moisture in the cable. The pairs or the individual wires were no longer just twisted into pairs, but they were quadruple-stranded, and color differentiation was used to make it easier to tell which particular element of the cable we were on. Of course, in recent years, fiber optics has also been going directly to the customers, to their homes, to their apartments, as you can see in these last samples here in the showcase. A typical fiber unit representative, 12 fibers. It's a very small, very lightweight cable that we're able to blow up to units of kilometers.